People think of transportation as logistics, but it's also storage, inventory, cross-docking, grouping, regrouping, and loading it into the right truck. The role of logistics. Logistics is very important for having the products where customers want to have them at the right moment, the right place, the right time, the right quality. That's sort of logistics. But in order to do that, we need not only transportation, and we also need the warehouses and the cross docks, because you can't just ship from a supplier in China, say, to some store where the customers want to pick up that product, or even a warehouse from where it's shipped if it would be an e-commerce product. So there is a long channel in between the manufacturer on one hand and the consumer who gets it on the other hand, and there's a lot of warehouses where all these products are stored and a lot of cross docks. I've been researching this topic for quite some time already, and I've seen quite some developments both in practice but also in academic research. So when I started doing this type of research, to be honest, research in material handling was close to non-existent. I can tell you since then a lot has changed. So we see a major shift in academic research from studies of ASR systems, and later it became to studies of more manual systems like a picker to parts type order picking, studies on routing, how to route the pickers, how to batch the orders. This type of studies. And now recently, that recently means the last 10-15 years, we see again a major shift in academic research, and that is on more automated systems. So I think Kiva systems gave a trigger for that, but also the rise of shuttle-based storage systems gave a rise to new types of topics within material handling, but also new types of methods. So we see also a shift in methodologies that have been used in academic research from, you might say, modeling ASR systems to scheduling methods, to also to more empirical research, and lately also queuing modeling, queuing network modeling type of research as method. And last but not least, also more empirical research based on experiments, for example, in behavioral operations. That's an interesting question. So, of course, we see more and more fully robotized warehouses evolving in practice, particularly in retail, and then even more precise in grocery retail. So I didn't do an exact count, but I estimate there are now, let's say, 40 warehouses or so in Europe, which are fully automated. When I say fully automated, it's not really 100% automated. There are still people working in these warehouses, but relatively few. So most of the key processes are robotized in these types of warehouses, automated. The bulk of the warehouses are just, well, there is some automation, obviously, there's mechanization, there's automation, but they're mostly just manual, run by people doing the key tasks. Now, what you see there is that also in these more manual warehouses, automation and robotization gradually are increasing. So yes, we see a higher level of automation, digitalization, for sure. I think many businesses are gradually increasing the level of automation. So I'm not sure whether it's dedicated to particular businesses, but of course it's more easy to automate. Well, it's easy to automate if you really have a strong constraint. So constraints force you to start looking into automation. What is a constraint? Like, we want to expand, there is no space. How can we still expand? Meaning, for example, more storage capacity, more throughput capacity, and we don't have the space to do it. Then you're forced to look into alternative solutions. The same is true when you don't have the people to do it. For example, we have to work more 24/7 at night. There are no people available at night, or we have to work with huge peaks. And there is no way we can find all the people to handle all these huge peaks. So if there are strong constraints, these are strong drivers for automation. Yeah, that's true. Say if warehouses get larger, and nowadays you have warehouses, not that many, but there are warehouses over 100,000 square meters. And simultaneously, these warehouses have to deliver large number of orders, particularly in business to consumer e-commerce. For example, the number of orders might be 100,000 on a day from a single warehouse. And if you pair that with a huge assortment, you have a very difficult task, because a huge assortment typically requires multiple storage conditions, and you cannot just store everything in a pallet rack, but some need to be stored in a shelf rack or a flow rack or some other storage conditions. All these different storage conditions means that the warehouse gets bigger. A bigger warehouse means longer travel distances. Longer travel distances mean longer throughput time. Longer throughput time means it's just more difficult to get it out on time. So it's indeed a huge challenge. However, these challenges can be overcome by, as many companies demonstrate this, by meticulous design. First, the proper design is important. So the layout of the warehouse, which type of systems do you choose? You have to really carefully look into all the conditions that products require, the throughput conditions, and then select the right system to do that. Then the software to control it all, and you need certain degrees of mechanization for sure, and probably also stronger degrees of automation. For example, parts to picker systems, so that you don't have to walk so much in these big warehouses. We bring the parts to the person, and then the picker doesn't have to walk and can achieve a very high productivity on the pick station. We design it very ergonomically, and then we can achieve high productivity of individual pickers. So I would say it's a combination of proper design of the warehouse, proper system selection, good allocation of the products to the right system, careful planning, and a pretty high degree of automation. It should basically be everything should work together. Good design with a good operation. So I think there are different types of automation you can go for. So the first one, it would be parts to picker systems. So there are now many different options for parts to picker systems. So varying from shuttle-based systems to Amazon robotics type of systems. With robotic mobile fulfillment systems, as they are called in literature. So small robots who bring racks to the pickers, to mini loads, the more traditional ones. So there are many different variants now of parts to picker. However, we also see now more and more variants of picker to parts. So picking with cobots. And that's also so while the parts to picker systems are quite expensive and require a drastical, you might say, overhaul of your design, picker to part systems, which are now robotized also, require not a major overhaul. You can gradually integrate it in your operation. So I think there are now more options, and particularly the parts to picker robots. I think we will see an increase in the future also in that type of systems. The systems have really matured, become really good. I think we see for those companies who don't want to make a major overhaul, they can just invest gradually in these types of systems. And by the way, if you have a parts to picker system, then we can now see the next phase, which is robotizing the order pick station. This will also grow quite rapidly, I think. So these are the two major developments I see in the future. Yeah, I think the future of warehousing is definitely going into more automation. So I think it's sort of unstoppable. That's due to multiple reasons. Like first, what is your competitor doing? But also the fact that we don't have sufficient labor, and we have a space shortage. This drives company into more automation. So even logistics service providers who have to make sure that they have generic systems, because the customers of today are maybe not the customers of tomorrow. So they choose in general for generic systems, but still even these companies invest in robots, in more automation. And they want to do that because they want to show to customers that they can also run these types of operations and can be attractive. And by using more robots, of course, you make yourself less dependent on labor. It's easier to work 24/7, also off hours, to prepare work, for example, or to do at least part of the work. So automation is here to come and here to stay.